Okay, so my first goal is to make the bases the same. And I know that 2 to the power of 3 is 8, and 2 to the power of 5 is 32. The thing is, I have 1 over 8. So what do I do to make this 1 over 8? What do I have to do here?
Negative.
Yep, make it a negative. So I can rewrite this problem. The exponents will stay the same, but this base, 1 over 8, can be written as 2 to the negative 3, and 32 can be written as 2 to the 5th power. So now your bases match. So now you just multiply these together and multiply these together. So negative 3 times negative 3x is a 9x. 5 times x is 5x, and 5 times negative 2 is negative 10. And then from here you just solve. So subtract 5x, you'll get 4x equals negative 10, divide by 4, and then simplify that. Do not leave it as that. You need to simplify all your fractions. Okay, so notice for this one I can't get the same base like I did in this previous problem where I got the bases to both be 2. So if you can't make the bases match, I'm going to take the log of both sides. And if you want to, you can make this log base 8 so that those cancel out. So now you're left with x plus 3 equals log base 8 of 200. And now you just solve for x. So you just need to subtract 3 from both sides. So this is what you'll type into the calculator. The answer was negative 0.45. Okay, so I want to get the natural log by itself. So what I'm going to do is add 6 to both sides. So now I have 3 times natural log x equals 9. Then you're going to divide both sides by 3. So you get the natural log of x is equal to 3. And if you want to get rid of the natural log, you can just do e to the power of natural log x. E to the power of 3. So those cancel out. So this is your answer. Just type that into the calculator. 20.09. You could do 3 to the power of 2 gives you this. 3 squared gives you x to the 5th. 3 squared is just 9. The way you get rid of a 5th root, or a 5th power, is you can do a 5th root. So those cancel out. And do the 5th root. If you type this into the calculator, you'll also get 1.55. So we want $20,000. We started with 8,000. Your rate as a decimal is 0.0627. So we're figuring out the time it took to reach 20,000. So when you guys divided both sides by 8,000, what did y'all get?
5 over 2.
What's that as a decimal?
2.5.
2.5, perfect. Okay, and I have this left over. Now, if you want to get rid of e, what should you do?
Natural log.
Natural log. So go ahead and take the natural log of both sides. And those will cancel out. So you are left with the natural log of 2.5 equals this, 0.0627t. What is my last step?
Divide by the 0.627.
Exactly. All right, so if you type this into the calculator, you will figure out the time it takes for $8,000 to grow to $20,000 when your interest rate is 6.27%. 6139. That's how long it takes. A paleontologist uncovers a fossil of a saber-toothed cat. He finds the specimen has 15% of its original carbon-14. So guys, if it now has only 15%, how much did it start off with?
100.
100%. Think about your cell phone. You start off with 100% and then it dies down and now it's only on 15%, okay? So the formula that's written on your paper is the half-life formula. All right, so this is what you guys have. I stands for the initial value. So your initial value is 100%. How do you write 100% as a decimal?
1.
Just 1.
1.
Okay. So we don't really have to write anything. And where is it now? What percent?
15.
15. We're going to write it as 0.15. Change it to a decimal. Okay. And they said that the half-life of carbon-14 is 5,730. So this is how we're setting up the problem. We are solving for T. That will tell us how old the fossil is. Now guys, this problem is similar to what we did previously. And let me show you what I'm going to do. I'm going to take the log of both sides. However, I would like these to cancel out. So what should I put as my base?
-2.
Do you guys remember this identity?
Oh,
If
just
these
1
are the
half.
same, it cancels.
1 half.
So I need this to be a 1/2 so that these cancel out. And if I do log with base of 1/2 on this side, I also need to do it to this side. So do log with the base of 1/2 on both sides. So this is what I'm left with. Log of 0.15 is equal to what's left over? T over 5,730. What's my final step to solve for T? Multiply, good, because right now this is being divided. So the opposite would be to multiply by 5,730. 5,730. So we're typing this into the calculator. All right, so the answer was 15,682.8. So the quotient property, whenever you're subtracting two logs and the bases are the same, you can divide the insides. So this one has an x, divide it by the 4. What is your base whenever it's not written?
10.
So you can write this as 10 squared gives you this. And 10 squared, that's just 100. And then can you guys solve? How am I going to solve for x?
We're gonna put it in a calculator.
You don't need a calculator. Multiply both sides by 4. This is being divided by 4, so the opposite would be to multiply by 4. So x is equal to 400. First, I'm going to do the product property. Whenever you have logs, you can combine it by multiplying these. So 4 times 2x is 8x. Now, to get rid of a natural log, you can do base e on both sides. So type this into the calculator. What is that equal to? Once you figure out what e to the power of 6 is equal to, then you just divide both sides by 8. So e in a natural log, those cancel out. So you're left with x to the 4th equals 16. Now you just want to get rid of this 4th, so you're going to take the 4th root, and those cancel out. You have to take the 4th root of this side. So guys, what is the 4th root of 16? 2, but also a -2. Because -2 4 times will also give you a positive 16. -2 and -2 is a positive 4. This right here is a positive 4. 4 and 4 is 16. So it's both positive 2 and a -2.
Miss Lewis, I thought you put in.
A negative into the problem. If you put in a -2 right here, -2 to the power of 4 becomes positive. So that still works. Wonderful, wonderful point. Okay, this one, I'm going to distribute this exponent. So I'm going to have log base 16. 4 squared is 16, and then you still have that x exponent. 4 squared is 16, and you still have that x as an exponent. And those cancel out. These match. So your answer is just x.
Yeah.
For this one, those cancel, your answer is just 5. These cancel, your answer is just 4x. This one, how can we rewrite 32?
2 to the power of 5.
Exactly. This can be 2 to the power of 5, and then your exponent is still 6. And remember, whenever you have exponents, you can multiply them. This is log base 2 of 30, and those cancel out. So your answer is just 30.
Let's go.
Whenever you have 1 over 3 to the 5th, you can flip it, bringing it to the numerator. And whenever you flip it, what happens to the exponent? It's now negative. Exactly. So I can write this as 3 to the negative 5. When you bring the 3 to the power of 5 to the numerator, it's now a negative exponent. Now, whenever you have exponent to another exponent, you just multiply them. So this is log base 3 of 3 to the negative 10. And these cancel out. So your answer is just negative 10. So whenever you're thinking of a log with base 2, you should think of the exponential with base 2. And this one we're very familiar with. These are the x values we're going to evaluate it at. 2 to the negative 2. 2 squared is just 4, but if you have a negative exponent, it becomes 1 over 4, which is 0.25. And then 2 to the negative 1 is just 2, but since it's a negative exponent, it's 1/2, or 0.5. 2 to the power of 0 is just 1, 2 to the power of 1 is 2, and 2 squared is 4. So this is the parent function of 2 to the x. However, when you have a log with the same base, your base is 2, all you have to do is flip this graph. So this is your new x column, 0.25, 0.5, 1, 2, 4. And then these are your new y values, negative 2, negative 1, 0, 1, and 2. So this is your new parent function table for log base 2. So this is what we're using. Now, your transformations, it went right 1 and up 3. So if it went to the right 1, we need to add 1 to all of these x values. And if it went up 3, we need to add 3 to all of the y values. 1.25, 1.5, 2, 3, 5. And then this is 1, 2, 3, 4, 5. Now remember, for a log, your asymptote, I like to put arrows on the L, it's vertical. And it went right 1. So I know my asymptote is at 1. Okay, so at 1, at 1.25, you're at 1. So 1.25, I'm at 1. Very close to the asymptote. And then at 1.5, I'm at 2. And then at 2, I'm at 3. 3, 4. And 5, 5. So that's my graph. So the transformations for this, you have a negative in the front, so that means it was reflected across the x-axis. And then it moved left 3. So here's your table for the parent function, 2 to the power of x. These are the x values I'm going to plug in, and these are the y values that are associated with it. Okay, so this is the parent function. However, when you reflect over the x-axis, so say you're right here, This is 3, 4. When you flip across the x-axis, it's now 3, negative 4. So notice the y value changed. So when you reflect over the x-axis, your y values change. That's this column. So I'm going to multiply all of these by a -1, or make them all negative. So I'm just going to make these all negative. Okay, and then it went left 3. Left 3, that's horizontal movement. That affects the x column. So if I went left 3, I'm going to subtract 3 from all of the x values. So these are my new points. My new points, I have -5 with -0.25, -4 with -0.5, -3 with -1, -2 with -2, -1 with -4. And then we'll plot those points. So -5 and -0.25. -4, -0.5. -3, -1. -2, -2. -1, -4. Right, so that's your graph. And since it didn't move up or down, your asymptote's still at 0. So this is your asymptote. So what we want to do first is get rid of that 5.
So you move it over.
So I'm left with 0.1 e to the 2x equals 4. So these are being multiplied. You have 0.1 times e to the 2x. So the opposite would be to divide by 0.1.
Oh, okay.
Now we have that exponential by itself. And 4 divided by 0.1, I believe, is 40.
Yeah, that's good.
Okay, so that was the part we were stuck on. Do you know what to do after this?
Yeah.
What do we do?
And then you have to cancel out the e, right? So you have to put it like, you have to do it like natural log before.
Exactly.
It's 3.69.
And then you divide by 2.
Mm-hmm.
And that would be the answer.
Okay, thank you.
Okay, so first I'm going to do the product property. I'm going to combine these into a single log by multiplying. So x times x is x squared, and x times the -3 is -3x. What is the base right here?
10.
10. So that means, do you guys remember this right here? If this base matches this base, then you can just cancel out?
Yes.
Okay, so I'm going to make,
Why'd you distribute the x?
this is the product property. So you distribute this to both of these because the rule is if you have log base m plus log base n, you can do a single log and multiply them.
Okay.
So this is called the product property. So we have 2 logs separated by a plus sign and the bases are the same. So the rule is you can multiply the insides. So that's what I did. X times both of these things. Okay, so my base here is 10. I can do base 10 on both sides so that those cancel. And you're left with x squared minus 3x equals 10 to the power of 1 is 10. Move this 10 over here to make it a minus 10. And now you can factor. 2 numbers that multiply to -10 but add to -3.
-5 and +2.
Perfect. So those are your factors. Let's solve it. This one will give you 5 and this one will give you -2. So if I plug a 5 back into the problem, this will still be positive. 5 minus 3, that's positive, so this is good.
Yeah.
Plug in a -2, nope, it's negative. And if you plug in here, negative.
Okay, so your answer is just 5.
Yep, just 5.